Hello to everyone. This is Shantan Kumar, Assistant Professor, Department of Mathematics, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. The subject is matrices. The topic today we are going to discuss on the definition and terminology, Module 1. The Module 1 is belongs to like matrices and calculus, like matrices. Under the matrices, we are going to discuss that particularly based on the rank of a matrix, homogeneous and non-homogeneous equations. Regarding these are the like three terminology together the topic that is a matrices. We are going to discuss the definition terminology. And in previous lectures we discussed that number of problems and also the theoretical concept in the matrices module 1. And moreover in the last session like that previous class are also completed, the question banks are also the module 1, like critical thinking and descriptive and also the essay type question and also short question type question. But today we are going to discuss that only the definition and terminology. A few definitions are occur under this module 1 that we are going to discuss that particularly that topics. Here the topic is model 1 is consisting like that these are the topics like rank of a matrix and echelon form, normal form and inverse of a matrix, non-singular matrices by Gauss-Jordan method, the system of linear equations, solving the system of homogeneous and non-homogeneous equations. Here the first one define the matrix. As we know that in the previous basic level also we studied that how to define the matrices and again what is the terminology like that, what is the denoted terms and again based upon that how to denote the rows and also columns and everything, the elements and again that the matrices are also denoted that how to discuss. But we know that, but today this is the define the matrices. That is nothing but a rectangular arrangement of elements in a row and columns. That means based upon the rows and also columns, we define that according to the construct that the matrix. And again, generally the matrices are denoted the symbols of like capital letters A, comma B, comma C, and again up to so on. The symbols are like according to like capital flower brackets and again the closed brackets and again open brackets and double script notations. These are generally the matrices are denoted, and based upon that here the definition is required. That is nothing but a rectangular arrangement of elements in a rows and also the columns. And next one that is a state the row matrix. And generally the row matrix is nothing but if any matrix is having like that only single row, it is called as a row matrix. That means a matrix with a single row, it is called as a row matrix. Like for example, it is a only 1 comma 2 comma 3. That is nothing but the rows are like the 1 and again the columns is nothing but the 3. And but here according to the row matrix is nothing but which is involving only one row. That based upon the order of the matrix is nothing but 1 cross 3 is a condition. And next one, define the column matrix. Define the column matrix is nothing but same like that row matrix. It is a column matrix is nothing but it is a single column. For example, it is a 1 comma 2 comma 3 for example the same matrix, and it is nothing but the number of rows are like that 3, but whereas the column is a 1 only. And based upon that the define the column matrix is nothing but we can define according to it is a simple terminology, it is a single column, that is a it is a column. A matrix with a single column it is called as a column matrix. Null matrix. The null matrix is nothing but it is whenever the matrix is consisting like that all the elements should be 0. That means how to define means it is a matrix in which all the elements are zeros. That means none other than any non-zero number it is a consisting. For example, it is generally it is denoted with a symbol is 0 or something based upon that m comma n. For example, 0 2 is nothing but the elements are rows and columns, and again it is a 0 0 0, that is a 0 2, and again it is a 0 3 is nothing but 0 0 0 0 0 0 0 0 0. These are like according to that null matrix, it is nothing but all the elements should be zeros. State the unit matrix. The state the unit matrix is nothing but it is the element should be it is a given matrix is particularly it is a square matrices, and again the diagonal element should be ones, and again the non-diagonal element should be 0. And generally in basic level, the unit matrix is denoted by the symbol is I. I is nothing but depend upon that. For example, IT is nothing but that is 1 0 0 1, and again I3 is nothing but it is a 1 0 0 0 1 0 and 0 0 1 is a matrix. This is nothing but the unit matrix, means it is a matrix is satisfied clearly, it is a square matrices, and moreover based upon the square matrices the diagonal element should be ones and the non-diagonal element should be zeros. A square matrix in which the diagonal elements is unity, all other elements being the 0 is called a unit matrix, or that is also called as a identity matrix. Real matrix. State the real matrix. The real matrix is nothing but when you are consider any matrix, it should be elements are satisfied the real elements only. That is not any other the complex matrices. A matrix in which every element is a real number only, other than like any complex number. Like for example, 1 2 3 and again 0 5 6 and 0 0 minus. But means it is a not belongs to any like complex value. Either the matrix is any like square matrix or any rectangular matrix. Next, define the complex matrix. Whereas the real matrix is different from the complex matrix, because of the real matrix should be satisfied like all the elements should be like real values only. And again here the complex is nothing but at least one of the element is a like complex number. Like for example, like that is also matrix is satisfied any like rectangular matrix or any horizontal matrix or something like column matrix or any matrix, either the square matrix are also, but at least one element should be it is a complex number, like 0 1 2 and 1 I 0 0 0 2. At least one of the elements should be it is a complex number. Like it is a any complex number. Such type of the matrix is said to be it is a complex matrix. A matrix in which at least one element should be it is a complex number is called as a complex matrix. Like symmetric matrix. The symmetric matrix is nothing but, for example, we consider any matrix like A is equal to, for example, it is a 1 2 3 and 4 5 6 and a 7 8 9. And based upon such type of the matrix, it should be it is A transpose. Generally, symmetric matrix is nothing but it is a like a transpose of the matrix is denoted the trans T, but the A transpose is nothing but the interchange of any rows and columns. It is a 1 like 2 3 and 4 5 6 7 8 9. For example, such type of this is the matrix is A, and again A transpose is equal like this. But here the definition of the like symmetric matrix, the meaning of based upon A comma A transpose, if it is A transpose is equal to that is A is the matrix is satisfied. That means the interchange of any transpose of the given matrix is satisfied, the given matrix is called that is a symmetric matrix. Here the definition wise, a transpose of the square matrix in which itself that is a transpose of A is equal that is a A. That is nothing but A transpose is equal to A is a matrix. And next one, that is a skew symmetric matrix. The skew symmetric matrix is nothing but same based upon the transpose symmetric matrix, but here the condition is the skew symmetric matrix should be it is A transpose is equal to the negative of the given matrix. That means when you consider any matrix A, we need to apply the transpose. We get that transpose of A is equal to the negative of the given matrix. That is A transpose is equal to A minus A is a condition is satisfied. That is the meaning of transpose of A is equal to minus A is a condition. But whereas here we need to remember, according to the skew symmetric matrix, the diagonal element should be like any zeros. The matrix is satisfied compulsory. That means the according to if the matrix is said to be like the skew symmetric matrix, compulsory the diagonal element should be it is a zero values. Yeah. Define the non-homogeneous equations. The define the non-homogeneous equation is nothing but as we know that Ax is going to be that is a system of linear equations. For example, we discussed previously the number of lectures in the like non-homogeneous equation problem wise, and also the question bank, and at the time of that theoretical concept also. But here also the definition we can define a system of linear equation, for example Ax is equal to b, in that b is not equal to 0. That means the equations is having the occur the constant terminology. That is the meaning of the non-homogeneous equations. That means in a equation Ax is equal to b, if b is not equal to 0, is called the non-homogeneous equations. State the homogeneous equations. Same like that, based upon the non-homogeneous equations, the homogeneous equation is nothing but, whereas under the homogeneous equation there is system of a linear equation Ax is equal to b, it is a b is equal to 0. That means based upon that equations are having, there is no constant terminology. That means Ax is equal to 0 equation, that is a system of equations are called, that is homogeneous equations. Yeah, that is the meaning of Ax is equal to b is an equation, b is equal to 0 is called, that is a homogeneous equations. These are under the system of linear equations. Next, explain about the trivial solutions. The trivial solution is nothing but when you are calculating that b, that is a data of a, the data of a is equal to automatically which is equal to 0. The data of a is equal, it is data of a is not equal to 0. While we are going to calculating like that under the particularly homogeneous equations, here by consider like that, pick out that a is a matrix. When you are calculating data of a is not equal to 0, condition is satisfied, such type of the equations are called as the trivial solutions. And moreover, at the time of the trivial solution, here all the solutions it may be 0, that is unique solutions. Next one, explain about the non-trivial solutions. Same based upon the trivial solution, but in the, under the homogeneous, it is also under the homogeneous equation. The trivial solution is nothing but when you are calculating, when you are considering pick out any the given matrix A, here you need to find out the data of A, that particular the given equation matrix, the coefficient matrix, the data of A is equal to 0. Therefore, the equations are said to be the non-trivial solutions. And at the time of the particularly the non-trivial solution, here we need to remember that equations are having, that is a number of infinite solutions it will be occur. That is rank of A is equal to less than n. But whereas the trivial solution, the rank of A is equal to n, but the non-trivial solution, rank of A is less than n is a condition. It is a non-trivial solution, infinite number of solutions. These are the under the system of homogeneous equation and linear equation and non-homogeneous linear equations. Let's define the nilpotent matrix. The nilpotent matrix is nothing but a matrix A is said to be nilpotent if M is a power of A is equal to I. That means the condition is satisfied, A power of M is equal to I is the condition. This is the condition of the nilpotent condition. For example, M is equal to N, in presence of M is equal to N, that is A power N is equal to I is the condition. That means given any matrix, if it is generally the matrix into matrix, that is a square is equal to, you obtain that unique matrix. That is the meaning of nilpotent matrix. And similarly, that other definition is also there. There is an involuntary matrix, but the involuntary matrix is nothing but a square is equal to, that is a 0. That is a involuntary matrix or something. Sorry, involuntary is nothing but a square is equal to, that is a is a matrix. That is a involuntary matrix. But the nilpotent matrix is nothing but a power of n is equal to, that is a I is the conditions. And recall the Gauss operations in the matrix. That means when you are going to calculating the Gauss operator, Gauss Jordan method, we need to remember the condition. That is recall the Gauss operations of a matrix. That is row operations. That means while we are going to calculating the Gauss Jordan method to find the inverse or something, any Gauss elimination method also, we need to applying only row operations, should not applying any column operations. And whereas in the normal form of a matrix, that is only row and column, that is echelon form is nothing but only the row operations. And again it is a Gauss operations of the matrix is nothing but it is a row operations. Define the rank of a matrix. That means, as we know that the number of different type of the terminology for the definition of the rank of a matrix, and in that briefly and also shortly it is available. That briefly is nothing but like shortly it is nothing but it is a maximum number of linearly independent of a matrix, and second one is like it is a largest order of any non-vanishing minor of a matrix, or it is the highest order of the non-zero determinant of the matrix. These are the three different type of the rank of a matrix it is available. But here, like mm, like briefly, if you want to say the rank of a matrix, R is the rank of a matrix, and again R plus 1 data is equal to automatically 0. Next one, define the order according to definition. It is briefly like that. If it is the rank of a matrix A is said to be R, then R plus 1, that it is a minor. Minor is nothing but it is that is equal to 0. For example, if it is the matrix is a 3 by 3, the data of data of 2 by 2 is equal to 0, is not equal to 0. Therefore, it is rank of a matrix, and moreover, based upon this one, the data of 3 by 3 is equal to 0. That means at the time of this rank of a matrix is a two condition. And based upon here also, if we say that rank of a matrix is R, that R plus 1 data is equal, that is a 0 conditions. Next one, define the order n identity matrix rank. That means it is a matrix is a rank of an identity matrix of order n is also n. That is the meaning of whenever the matrix is in, that is unit matrix of order n, the rank is also the data of n by n is not equal to 0. That means, for example, the matrix is I2, that is a data of the 2 by 2 is not equal to, that is a 0. And similarly, that I3 is nothing but the data of, that is a 3 by 3 is not equal to 0. That is the meaning of here. The n is identity matrix of order n. Therefore, rank is also the particularly unit matrix of order n is the conditions. What is the diagonal matrix S rank? That means is the order of the given matrix. That means whatever the diagonal matrix, for example, it is the diagonal matrix is like that according to 1 0 0 0 2 0 0 0 3. This is the one type of the diagonal matrix. Because of here that 3 by 3 is a square matrix, and moreover the non-diagonal elements are 0. That means the diagonal matrix is a 3 by 3, then automatically the rank is also clearly, the rank of the matrix is the clearly 3 is the matrix. That means based upon that it is a diagonal matrix S is the rank, then automatically whatever the given the order of the matrix, that is the rank of the matrix. Next one, the diagonal elements of the matrix which is a skew symmetric matrix. The diagonal elements of the matrix which is a skew symmetric matrix means whenever the matrix is the skew symmetric matrix, here the particularly they are asking what is the condition for the skew symmetric matrix diagonal elements. That means indirectly the diagonal element should be, that is a zeros. That means according to the definition of the skew symmetric matrix, whenever the matrix is satisfied like that A transpose is equal to, that is a minus A, and based upon this one the diagonal elements are, that is a 0. The diagonal elements are, that is a zeros. This point we need to remember according to at the time of the calculation of the skew symmetric matrix. Next, I think it is a final, that is a state the diagonal elements of a skew Hermitian matrix. That means here also actually the Hermitian matrix is nothing but A power theta is equal to, that is A. Otherwise, that is A conjugate A transpose is equal to, that is A transpose. And here, based upon this one, it is a skew Hermitian matrix is nothing but A power transpose is equal to minus A. Otherwise, A conjugate is equal to minus A transpose is the conditions. This is the meaning of the conjugate of the transpose of the matrix is equal to the negative of the given matrix is called, that is a skew Hermitian matrix. But here, based upon this is the, whenever the matrix is a skew Hermitian matrix is satisfied, according to the diagonal element should be either the zeros or purely imaginary numbers. Either the zeros are purely imaginary numbers. Whereas in the skew symmetric matrix, it is all the elements should be zeros. But according to whenever it is a skew Hermitian matrix, it is a little bit, at least one is a like a complex number also, like a pure imaginary number is also available, including the zeros. That means according to the matrix is said to be skew Hermitian matrix, the diagonal element should be clearly like either the zeros are any purely imaginary numbers. Define the singular matrix. The singular matrix is nothing but when it is particularly it is check that at the time of the inverse of the matrix, the data of A is equal to that is a 0. That means when the given matrix is any square matrices, we need to calculate the determinant of the given matrix. The data of the matrix would be that is a 0. If determinant of it is zeros, determinant of the value is 0. And next one, define the non-singular matrices. Similarly, when you are going to calculate the data of any square matrix given the matrix, we need to calculate the data of the matrix, and it is data is equal to not equal to 0. And again, if it is a data is not equal to 0, automatically inverse is exist. It is useful for at the time of that finding the inverse of the matrix. State the inverse of an identity matrix. The inverse of the matrix is nothing but it is a transfer like adjoint of A by data of the given matrix. Yeah, inverse of an identity matrix is nothing but it is an identity matrix only. Because of A into A inverse is equal, that is I. That I into I inverse is also nothing but I is a matrix. Yeah. State that define the principal diagonal matrix of the elements. Matrix. Principal diagonal matrix. The principal diagonal matrix is nothing but the elements in the leading diagonal elements. That is the meaning of the principal diagonal elements. That means elements of the, like for example, it is a 1 comma 2 comma 3 and 0 comma 5 comma 6 and 0 0, like 8 and also 9. Here what are the like principal diagonal matrix of the elements is nothing but whatever it is the principal diagonal element, these are the principal diagonal matrix of the matrix. These are the meaning of the leading diagonal elements. State the rectangular matrix. That is basically the rectangular matrix is nothing but it is a the number of rows is not equal to the number of columns of the given matrix. It is called as a the rectangular matrix. If the number of rows is not equal to the number of columns, it is called as a rectangular matrix. Define the square matrix. That is also nothing but the number of rows. The number of rows is equal to the number of columns. That is the meaning of if the number of rows is equal to the number of columns. If determinant of the third order matrix is 0, then rank is. That means if the determinant of the third order, that means the data that is a 3 by 3 is equal to 0. Then what is the rank of this matrix? That means whenever the matrix is the data is equal to 0, that is the rank is nothing but that is a less than that particularly order. Yeah, that is a less than or equal to that is 2. Because of it is a 3 by 3, that data is 0 is nothing but it is a less than or equal to 3. That is the meaning of the like less than or equal to that is a 3. Yeah, less than or equal to, sorry, that is less than or equal to is a rank of the matrix because of the condition is satisfied. That is the conditions. What is the rank of null matrix? According to the rank of a matrix, if you want to say that every matrix will have a rank, and moreover, if all the elements should be like any non-zero number, it should be compulsory. It is a more than the rank is a 0. But especially the given matrix is a elements are 0, then only the rank of a matrix is a null matrix. Whenever that is the meaning of it is a all the elements should be zeros. Define the minor of the matrix. The minor of the matrix is nothing but particularly if the given matrix, any matrix is given, we need to find out that particularly the element of the determinant value, we need to find the solution. That means after deleting, neglecting that particular row and also the column, we need to find the determinant. That is the meaning of the minus of the matrix. Minus of the element is nothing but it is the determinant of the matrix obtained by deleting rows and columns where it is a present a particular value. For example, if it is a 3 by 3, we need to take any particular value. We need to find that minor means that particular value where we are going to calculating that particular value, you can delete the rows and columns. The rest of the values we need to find the relative. That is the meaning of the minus of the matrix, that particular element. Every complex square matrix can be uniquely expressed as complex square matrix. That means expressed as the sum of the Hermitian and square Hermitian matrix. the sum of the Hermitian and skew Hermitian matrix. That is a uniquely. That related to other properties also there. Every matrix can be uniquely expressed as a sum of the every matrix can be uniquely expressed as a sum of the symmetric and symmetric matrix. But here the every complex square matrix can be uniquely expressed as the sum of the Hermitian and skew Hermitian matrix. These are the definitions are occur under this is the module 1, that is the rank of a matrix, and homogeneous and also non-homogeneous equation. These are the particular like definitions under the module 1, that is a matrices and the topics. I hope everybody understood. And again, the other basic definitions are also occurred, but as per it is syllabus, it is not required that much of the other definitions are not required. I hope everybody understood based upon these are the definition terminology. And again, wish you all the best. And again, further in the next session, we'll go to start based upon the module 2, that is eigenvalues and eigenvectors, the definition and terminology. Thank you. If any doubts or any clarifications are required, please give me the reply to following the link only. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.